Hello guys, welcome back to my channel, and in today's video we are going to learn about logistic regression, how to conduct logistic regression in SPSS. So the first thing that we are supposed to understand is what is logistic regression. So logistic regression is statistical method used to predict the probability that an observation belongs to one of two categorical. Unlike linear regression analysis, which predicts a continuous value such as income or crop yield, for logistic regression predicts a binary outcome. For example, where we have yes or no, and then we have disease or no disease, where we have people adopting technology and others not adopting technology. So for you to conduct logistic regression, you need to have your data. So if you don't have your data, go to file and then you import your data. So we have the data, so you go to analyze, regression, and then binary. So we have this output, we have this window which has the logistic, which is written logistic regression and has dependent and the independent variable. So you're going to pick the dependent variable to here. So for our dependent variable, it's the adopt. And then for the covariate, we are going to pick all these independent variable. Then we come to categorical. So we are going to the categorical here and then continue. And then options, we ensure that Hosmer, Lemeshow is clicked. Then we have the confidence interval also be clicked, and then include constant model. Click continue, and then click OK to get your results. So we have our results, and then we can start now doing some interpretation. So we have the this case processing summary, where it shows you the number of cases that you had in your data. So we had 20 cases, and we don't have any missing case. So sorry. So for dependent variable table, we have the encoding, which is giving you the binary 0 and 1. And then for categorical variables coding, also it's giving you for credit 0 and 1, training 0 and 1. And then we have the frequency here, and then the parameter coding. And then we have this beginning block where we have adopt 0 and 1. So then we have these variables, and then we have this variable not in the equation. So the first important table that you need to look at when it comes to logistic regression is this table, Omnibus test of model coefficients. So for you to interpret this table, you look at the chi-square, degree of freedom, and then significant. So here, how do you write this interpretation? So you write this interpretation chi-square, which is chi-square written in x, subscript, there's superscript 2, and then is equal to 27.526. Indicates that the improvement in model fit after adding the 5 independent variable, and then degree of freedom is equal to 5. So, and the significant is value is equal to 0.000. So how do you write your interpretation? So you write your interpretation like this. You say the omnibus test of model coefficients show that the logistic regression model was statistically significant. And then now you need to write the chi-square, and then the degree of freedom in bracket 5 is equal to this 27.526, and then the p-value you write less than 0.01. This indicates that the model containing the predictor variable fits the data significantly better than the intercept-only model. Therefore, the sets of independent variable significantly predicts the dependent variable. So here we have uh, how you can write. So this is what I was saying. So for your interpretation, if you are using the APS style, this is how you're supposed to write. And then if you're doing thesis, so you need to write the omnibus test of model coefficients was statistically significant. And then the chi-square is equal to 27.526, degree of freedom 5, p-value less than 0.001, indicating that the inclusion of the 5 predictors variables significantly improve the model ability to predict the outcome variable compared to model without predictors. Thus, the logistic regression model provides a better fit to the data than the model. So after you interpret the omnibus test for the logistic regression, you come to what we call the model summary. So for the model summary, we have the log likelihood, we have the Cox and Snell R square, and then the Nagelkerke R square. Also, this is a very important table that you need to uh, interpret. So for you to you look at the p the you look at the likelihood, which indicates perfect fit because it is less than 0.05. So and then we have also the Cox and Snell. You need also to write something about it. So how do you write it? So you need to write like this. The logistic regression model demonstrates an excellent fit to the data with. You come and write the -2 log likelihood of 0.000. And then you continue writing the Cox and Snell R square, and Snell R square was 0.747, indicating that approximately your time is now this by 100, approximately 74.7% of the variation in the independent variable was explained by the predictor variables. And then you come also and explain them this. So you say the Nagelkerke R square was 1.00, suggesting that the model accounted for 100% of the variation in the outcome variable, indicating a perfect model. So if you are a student, so you need to interpret the model as this. If you are writing your thesis, dissertation, this is how you're supposed to put the model summary indicated that the logistic regression model provided an excellent fit to the data. So that the -2 likelihood value of 0.00 reflects an optimal fit of the model to the observed data. And then you need to also write about the Cox and Snell, which is 0.747, suggests that the independent variable explain approximately 74.7% of the variation in the independent variable. Furthermore, you need to explain the Nagelkerke. Yes, so you explain like this. Uh, um, indicates that the model accounted for all the variation in the outcome variable, demonstrating a perfect predict model. So these are very important tables that you need to interpret before you move to the other table. And then we have also the Hosmer and the Lemeshow test, which is very important and you need to interpret. So for our Hosmer and Lemeshow, we have the chi-square 0.00, degree of freedom 5, and the significant is 1. So this Hosmer and Lemeshow goodness of fit tests evaluate whether there is a significant difference between the observed and the predicted values of the dependent variable. So how do you interpret this? You need to look at the p-value, which is greater than 0.05. So in case if you had a null hypothesis, you are going to write it as null hypothesis is not rejected. This indicates that there is no statistically significant difference between the observed outcomes and those predicted by logistic regression model. Therefore, the model demonstrates an excellent fit to the data. So this is also very important, because if it is not fitting the model, you need to go back and look at your data. You are not going to go further and start doing another interpretation. So these are very important tables that you need to understand first if it is fitting. So we were talking about the model, and the model indicates the logistic regression model fits the observed data exceptional when we were in the model. And then when we were in the omnibus test, this one has few it helps to test whether the logistic regression model containing the predictor variables fit the data significantly better than the model with no predictors. But when we come to Hosmer, we are looking at um, to test and evaluate whether there is significant difference between those observed and predicted variables. So let's say that you have interpreted all of them, and you know, if you do one by one, it is going to make your report to be bigger. So you can bring all of them, and then assuming